Hello, everyone. Thank you for coming to another OpenShift Commons community call. My name is Karina Angel, and really excited to have Miguel and Pablo here with us today to talk about Microshift and Edge and new things that are happening. So we are going to go ahead and get this started, and I am going to pass this off to both of you to introduce yourselves and Pablo to kick it off. Thank you so much.
Okay, so I'm Pablo Aceveda. I'm team lead for Microshift, and today I'll be talking about Microshift.
And hello, I'm Miguel. I work at the Edge team for emerging technologies at Red Hat, and I'm working on a new project called Jumpstarter, and yeah, I will share what we are doing.
Okay, so let me share. I will put this in slideshow. Okay, so today I will be talking about Microshift, and talking about Microshift kind of implies talking about Red Hat Device Edge because it's part of the same stack. So what we are used to see is the stuff on the right, which is running all of the traditional applications, AI, machine learning, cloud native, hyper scalable applications and everything. All of this usually runs on the cloud and in data centers. Now there is an uptrend about Edge, and we are trying, or the approach of the company is to try to move all of those things that were traditionally running on cloud to run them on the edge. And that's the edge, it differs from the meaning of what's edge. It differs from one person to another, but usually it's something that as far as you go from the data center, you are more edgy, let's say. So you have regional data centers, remote sites, and it goes as far as edge devices. And by that, I mean, well, any device you could think of. So for example, something in a retail store or something in a factory floor. There are many edge devices and different categories of edge. So what are the challenges when trying to move to the edge? Well, first and foremost, and the most obvious one, is limited resources. Obviously, you need to run on devices that you are not running on the cloud. So you don't have these server hardware available and scalable hardware. You are typically constrained to devices that have a fixed amount of CPU, fixed amount of memory. Sometimes it's not even the same hardware as in data centers. So for example, you don't get x86 and you get ARM instead, or you get devices that are more focused on throughput to power, throughput to cost per watt, and many other distinctive characteristics that the edge has. Then another big issue, or well, not issue, challenge, is how do you manage your platform and your application when it's running on the edge? By that we mean it might be, well, you don't have all of the connectivity and all of the easy ways of configuring, managing your applications. So it might be in remote sites with no connectivity. It might be on, for example, on a windmill, and every time you need to do something, someone has to climb up there. So this means that management is different. You need to have as much automation as possible here. You don't usually have the easy way out of saying just connect to it and do whatever you want. Sometimes you don't get that luxury. And the third characteristic of Edge is that you are not running on a single cloud or a single application over a cloud. You might be dealing with hundreds, thousands, or hundreds of thousands of devices. So you need a good way to manage that and to scale accordingly and not get eaten up by all the complexity. This is the the different categories of Edge and all of the platforms that Red Hat offers. So below Red Hat OpenShift, you see all of the different ways of deploying or using OpenShift. You have the clouds for data centers. This is not the Edge. This is where the Edge applications will be connecting to. You have regional data centers. That's Edge. And then you have the so-called far Edge, which is even farther from the cloud. And for OpenShift, you might already know, you have the typical 3-node clusters. Then you also have remote worker nodes, Hypershift, and all of those different deployments. You also have single node OpenShift. And then to try to move this even, because single node OpenShift is a bit hard on resources. It can't run anywhere because it's a bit heavy on the requirements. For that, you have Microshift, which is right on top. And it's also running on something that we call RHEL for Edge, which is a different flavor of Red Hat Enterprise Linux. And this is specifically RHEL for Edge. So RHEL for Edge is Red Hat Enterprise Linux, which is running also RPM OS 3, which makes the whole OS immutable. And you maintain state over only 2 directories, and then all of the rest of the file system is immutable, so you cannot change it. So this has, and this links with the easy management. The way to change something here is to stage those changes, and those will be applied over the next update, over the next boot, and that happens atomically. Or transactionally, actually. So this makes updates quite easy. You can reproduce issues. You can track what happened, differences, everything. So this makes all of the configuration and all of the management of the OS way easier than a regular RHEL system. And this is done on purpose. Another big characteristic of RHEL for Edge is greenboot. So whenever you reboot, there is this application called, this system service called greenboot. So what it does is it runs a set of checks that need to pass. And if they don't pass, then there is an automatic rollback of the update. So it goes to the previous well-known state. So you are always left with a working system. And this is quite useful in when upgrading applications. So it comes in quite handy. Microshift does use this from the GA version. And then the other challenge with management is the device onboarding. So typically what you get is you mass produce these devices, and then you ship them to the place where they are going to be installed and deployed. And then what you usually do, what we are used to do in cloud applications and data center applications, is that someone or some automatic process will start installing everything. So with this, because of all the challenges that we already saw that you have in Edge, it might not be always the case that you can do this. You might need to do this with thousands of devices. Sometimes you need to install them in far locations where you don't even get access to it. So this is what RHEL for Edge provides for that, which is the device on board. As soon as it comes up, and this is about late binding the devices to a management platform. So as soon as it comes up, it will identify itself to a backend server with device on board, and then it will start getting all of the configuration and all of the software that it needs to boot. So this is usually, or colloquially, described as power on and walk out. So this is something that RHEL for Edge also provides. And then you enter Microshift. We already spoke about the OS, but we have not run anything yet on it. So what is Microshift? Well, if you want to run your applications in containers, you would think first of, why don't we run this on Podman over RHEL for Edge? And that's where Microshift comes in. On the right, you can see some summary of customer use cases for Microshift. And you have several of those which are quite important. So for example, standardizing on the software lifecycle management. If you have your own applications and you want to deploy them over a Rail for Edge system, you either have something that resembles the rest of your platform, which is typically Kubernetes or OpenShift, or you have to write specific changes for your application to run over Podman. So that's one of the biggest selling points of this. Then you also have the ability to orchestrate those containers. Podman doesn't give you that. Kubernetes does because it's specifically made for that. You also have a consistent development and operational experience across all of your different deployment types, because it's the same thing. You don't care where it's running, because on the administration side, it looks just about the same. You are also able to rely on off-the-shelf services. There we list, for example, Kubeflow, but you have any other, well, Prometheus, for example, or well, whatever you can install in regular Kubernetes. And then, of course, the biggest one, which is the right sizing, availability, and capacity. Single node. Some customers need single node, and they don't want to move from that because they don't want to run into the complexity of having a multi-node cluster. So their alternative for that is just start more instances of this instead of adding nodes to it. So these are the reasons of existence for Microshift, and this is how Microshift looks like when compared to OpenShift. So on the right, you see OpenShift as a single stack that manages from the lowest level, which is the lowest in terms of OS. It runs from the OS up to your cluster services, up to right before your application. And it manages the OS, it manages Linux, it manages all of the Kubernetes software and configuration and management. And you also have all of the cluster services that OpenShift provides in terms of, well, in the form of operators, networking, ingress, storage, and all of that. On the left, you have Red Hat devices. So you have as separate logical instances. You have the OS, which is Linux for Edge, and that takes care of all of the OS-related stuff that you need. And then you have Microshift, which runs just as another application on top of the OS. It doesn't do anything with the OS. It only cares about the applications and their interaction with all of the cluster services. But it doesn't change anything at OS level. That's, well, it's an application. So what were the design goals for Microshift? Well, first and foremost, obviously, because it needs to run on the edge, we need minimal deployment, which means we need to run only what we need, the core services from Kubernetes, a few optional add-ons, and those are security context constraints from OpenShift and also routes. And that's it. The rest is the user responsibility on what they want to install, what they want to run, and what they want to manage. The second goal, and this one stems from the first one, it needs to be resource efficient. So right now we are sitting at a minimum requirement of 2 cores, 2 gigs of memory, and 2 gigs of storage for running Microshift. And there is a bit of slack in those numbers, but that's the minimum that we required. And in order to keep it simple, we also had the design goal of making it monolith, to be able to atomically start and stop the service. And to remove orchestration, we needed to have cheap, fast, and easy restarts. So this was another design goal. It needed to be familiar to Linux admins. We didn't want to require more knowledge or certification for being able to use it. So it handles just like another Linux RPM. You don't really need to know anything about Kubernetes or OpenShift to manage it. As it is also an application running on top of Rail, it had to have the minimum amount of configuration, and if possible, it needed to configure itself or discover what its configuration should be. built for RHEL. Right now, we only support RHEL, and the community version is out of scope as of today. I cannot guarantee when that will come. It needs to run with the least privileges because it's an application and it doesn't handle or manage the OS in any way. And also, the other big requirement specific for Edge is the need to be able to run without network, with expensive or slow network, firewalls, anything. It needs to run over non-common systems. This is how the architecture looks like. So you have the Microshift binary, and in there you see all of the components that it embeds inside. It has the API server, it has the scheduler, it has the config manager, it has some of the OpenShift API in terms of SCCs and routes, some configuration management. It also runs the kubelet, and then it runs some of the controllers from OpenShift as well, which are right there as add-on component manifests. etcd runs as a separate binary, but it's also part of the service. And then we also run on Cryo, and then as additional components or things that you see when you're running Microshift and it's fresh installed, you have the service CA, you have the OpenShift DNS, you have an ingress controller in the form of the OpenShift router, and you also have CNI, which is OVNK, and the storage provider, or CSI, which is TopOLVM right now. And this is how it looks like. We use the file system, the OS file system, to store all of the Microshift data and also all of the images that we need. And you can build Microshift to be able to install offline, of course, because this is also a use case. So the Microshift RPMs are, well, actually the OS, because this runs on RHEL for Edge. So the image for RHEL for Edge can also contain all of the offline images and all of the offline manifests, so that it doesn't require a network. And this is how it's all of the OpenShift components that we ingest from an OpenShift release image, because we align with all of the OpenShift releases. So when OpenShift releases 4.14, for example, Microshift is also based on the same core components of 4.14. So it uses the same source code. And you see it's some of the OpenShift source code is rendered in our components. Some of the components of the component manifests are embedded within Microshift core components. And then the OpenShift component images are used by the same images are used by our add-on components in Microshift. And that's what I had for today, because I didn't know how much time I had. Maybe I went in a little bit too fast, but that's a brief overview of how Microshift came to be and how it looks like. And as another add-on, we are working with some partners that they have been working quite closely with us. One of them is ABB, and we have been working with them quite successfully to run their Edge platform on factory floors for some industry applications. And we also have as an early customer Lockheed Martin, which is planning to use it for AI processing on images and disconnected use cases. And we have a few others on the line, but those are the first two real customer use cases that we have for Microshift. And that's it. If you have any questions.
Hey, Pablo, there were a couple of questions that came up. Sure. Miguel and I were answering them, but maybe you could take them live here. One was asking about the difference between Microshift and HyperShift.
Yes, well, HyperShift is intended for a different use case. HyperShift is intended for cloud, actually, and running control planes separate from the worker nodes. Microshift is about the opposite. It's about centralizing all of your control plane and worker nodes inside the same device, and also running in Edge. So you can see Microshift as a tiny, minimal OpenShift version, to run in resource-constrained environments.
Right. So I think in a previous slide, you were showing different deployments that are gradually getting us to edge, to device edge. And one of those components, so these remote worker nodes, that's the Hypershift deployment.
Exactly.
Whereas device edge would be either, device edge would include Microshift and the Red Hat Enterprise, Red Hat Linux Edge, right?
Exactly. Yeah. RHEL for Edge. Yes.
Yep.
And I see another question. Can I use confidential containers on Microshift? What do you mean by confidential? Well, as long as you provide pull secrets, you can use whatever. This runs just like any other Kubernetes distribution.
Yeah, I'm not. I'm not super familiar with confidential containers yet, but if you can run it on OpenShift and the operating system is able to run it normally, there are chances that it's going to work. But we'll need to ask the experts.
Yeah, and there is an ebook out there that talks more in depth about security at the edge. So if anybody wants to download that, that might give a little bit more information on the questions that are coming up.
We have binary compatibility in RHEL for Edge with OpenShift. So if it runs in OpenShift, it should run on Red Hat device edge.
Mm-hmm. And Babuni had a question as well. Let me see if I can unmute him. Go ahead.
Yeah. Yep. Sorry. Thank you. Actually, I have a bit doubt about the Microshift. As you said, actually, I'm working on the OpenShift cluster. But as you said, Microshift is a very minimal of OpenShift cluster. So the question is here, like in OpenShift, we have 3 master and n number of worker node. So what about Microshift? Only one in all one node cluster, or also we can add multiple nodes?
You can, well, adding multiple nodes is not supported, and right now we stick to only one node for everything, for the control plane and the workers.
Okay, but OpenShift is providing SNO, single node of OpenShift cluster. Then what is the difference between Microshift and SNO?
Well, that's the gold question. Single node OpenShift is much, much bigger than, it requires much more hardware than Microshift. And operating it is a bit more complex because it has a lot more features. That's the big difference between them. Microshift is engineered for really, really resource-constrained deployments.
Yeah, think of it this way. We've been gradually getting closer and closer to the device edge, right? And so as we released the 3-node compact clusters, that was the ability for us to, have smaller deployments out past the enterprise edge, provider edge. And then as we looked at, incorporating Hypershift and remote worker nodes, that gave the ability to spread out our worker nodes. Single node OpenShift was getting everything down into one single node, but it's still pretty resource intensive. Device edge is really meant to get all the way out to that device, right? So by necessity, that needs to be a very, very, very small deployment. So it gives you that continuum to get all the way out to device edge.
Okay, last one question. Is Microshift supported for production deployment, and is Microshift supported by Red Hat?
We are planning to go GA by the end of this month, beginning of the next one. So yes, but not yet. Right now we are in tech preview. 4.13 is tech preview. 4.14 is meant to be GA.
Okay, is it supported by Red Hat in future if I am using on production environment and getting some issues, unable to fix that?
Yes, from
Okay,
4.14. Yes.
thank you. Yeah.
Great. And I think there was another question here around Kafka or Red
Yes.
Hat AMQ.
AMQ.
And with this, I have to jump to another call. I see that Karina's back, so I'm going to turn things back over to Karina. Thanks so much, Pablo.
Thanks, Mike.
Thank you, Michael. So yeah, that question about what Red Hat AMQ or Kafka connections to sensors, where does Microshift connect to that? Those are applications running on the cluster, so they should be able to run on Microshift. We haven't tested yet integration with those components, but they are just, well, they are workloads running on top of the cluster.
I've run them locally for testing when we were developing the initial versions of Microsoft. I don't know today, but at least in the past, you could run just a broker and then connect devices via, for example, MQTT and have the translation to other types of queues, and it ran pretty well.
Yes. Well, I have seen that working, but we don't support it officially yet because we haven't tested.
All right, are there any more questions? It's fantastic.
Real quick, I know you guys. Oops, I got to echo. I know you guys usually send these out, and I've seen this slide before, but I'd love to get my hands on it and borrow it in my own deck, if that's all right.
Yeah, absolutely. I will share the slide deck.
Thank you.
Thank you. Thank you, everyone.
Thank you so much, Pablo. Okay. Atif, I'll send out the slides. I'll put it in the notes document where they will be. And for their Red Hat employees on here, we'll send them internally for use. Okay. And with that, thank you again. And Miguel, would you like to take it away?
Okay. So yeah, let me continue where Pablo ended. So now imagine that you are working with edge devices and you have already built your image for your application in Microshift. It could be even without Microshift, but let's imagine that it's with Microshift. It's what we were talking about. So you have the image for your device that you have built maybe in your OpenShift cluster because you have a new version of your application or you have a new version of Microshift and you want to get the image update. So at that point, something that you may want to do is test your image on real hardware. Let me share the screen. Okay. Can you see the slides?
Yes, thank you.
Okay. So, so this is when the Jumpstarter project comes. We are trying to implement hardware in the loop testing together with OpenShift for edge customers and for partners. And this is a project from Emerging Technologies at Red Hat. This is still not a product. It's just a prototype, as Microsoft was at some point. And so we are trying to address the gap of we have software that we had built for run on one of those devices, and we need to test it. And in the data center world, it's very easy. We have plenty of virtualization. We can start bare metal hosts if we need to, and we can test our software. I mean, we are completely used to that at this point. But with edge devices, we don't have out-of-band management, so it's difficult to test. Normally, people will do it manually in most companies, or maybe they already implemented something like we are something like Jumpstarter, but they did it with a lot of scripts, and I don't know. If they switch to another platform, they need to do a lot of scripting. So this is what I will skip a few slides and go a little bit quick because I want to get into a live demo, hopefully. So yeah, this is how it looks today. This is how DALI imagined what I was trying to explain. So there is a human operator getting the devices that your company is building and flashing the software that you just built and then testing it, making sure that it boots, that the kernel drivers are loading, that the interface is working. So it's done manually. But we're trying to change that. So you can integrate the testing of your images in a DevOps way. So as we said, you have your software that has changed, or maybe there is a new release of Microshift. So your pipelines build an image for your device. And at this point, you are ready to test it and make sure, okay, is everything right? So this slide was up to date, like 1 hour ago, and now I finally managed to run it on Tecton because that is something that I wanted to show for this meeting to make it more relevant. So the idea is that the Jumpstarter software can connect and manage those devices like if they were servers. We have a driver architecture to let you use different things. Currently, we only have one because we needed something to show. So this project involves a little bit of open hardware today. This is, I don't know, not very usual at Red Hat, but we did it this way because there was also a gap in having something standard to put your hardware. Probably you have custom hardware where your software is running and you want to test it on that hardware and you really want to automate it. But I mean, there was no open source solution and nothing that we could get working here easily. So we made this piece of open source hardware that allows you to connect, as we showed in this previous slide. It allows you to connect a number of your edge devices to a cluster. In this case, it's a GitLab runner, but it could be one of your nodes in your OpenShift cluster to be used with Tecton. So this is, for example, how it looks if you have an embedded device. In this case, it's a RISC-V embedded board. And the idea is that we can connect a storage device to the testing device, and we can also talk to the device via a console. If you see here, there is a connection. You can also manage the pins. So we have more like additional pins that we can control here to put it into flashing mode, to reboot it, to power on, power off. And so, yeah, I can probably skip a little bit of the details here of how it works. Yeah, something that we also plan is power metering. So edge devices, in some cases, need to run off battery. And and maybe solar power. So it's very important for some customers to know if the changes that they made to their software or the changes that happened in the operating system or the drivers are not making a big difference in how power is consumed on the devices. Because maybe if that is happening, the current hardware is not going to work on the field. Like the battery maybe will be consumed overnight, and then the device will switch off. So that kind of change needs to be detected. That is something that we want to implement. It's not, I mean, we have it on the hardware and we have it on the firmware in the hardware, but not in the Jumpstarter software yet. So the idea is that you can write to test those devices. Once you have an image that you want to test, is that you can use scripts made for Jumpstarter, where you are selecting what type of device you want. If you have multiple types of devices, maybe I want this type. So this script will, when it's running, will look for one of those devices, and if none is available, it will wait until one is available or eventually time out. So what this script is doing is making sure that the device is powered off, then it's writing the image to the USB disk that we could see on the picture before. Then it's going to connect this USB device to the Edge device and then power on. Then we are waiting on the console for a login with root and Red Hat in this case, because we injected that username and password on the image just for the testing version. Of course, don't send any device on the field with fixed user and password. And then when we want to go and make more complex tasks, we can create an Ansible inventory. Oops, sorry. We can create an Ansible inventory and continue with Ansible. We also want to enable other tools. This is why we are just allowing cell runs. Then we have a cleanup section that is going to trigger if something goes wrong. Then the cleanup section will trigger. What you normally put in there is detaching the storage and powering off the device, so it's not consuming power on the data center or your lab. So, and this is how it looks. If in this case, this is something that we were running we have it actually running on a GitLab runner for some of the software that we build in Red Hat together with NVIDIA. And this is how it looks. If you run a script, the script that I was showing before is going to look for the storage of this device. It's going to write to the USB storage, power on, and then we see the boot sequence. Well, this is the more internal stuff, like trying to explain to my colleagues in Red Hat. Normally we don't make hardware, but we are looking for partners to make this hardware. And also it's the hardware part is an open source design. So I have it here on the side. It's an open source design, and all the manufacturing files are available. So you can just send the files to any manufacturing house, and it's not very expensive to make. And they will send you a batch of the boards. With this, let me show you how we run it on Tecton. Here, let me look for my camera first. I will stop sharing for a second. And please feel free to make questions, because this topic, I tend to see that it's a little bit confusing. It's a little bit complex. So here on this side, let me remove the portrait. We have one of those boards on the wall, and I have a couple more up there on cases. They are just connected to a single node OpenShift in this case. Okay, so they are accessible to Tecton. Now, okay, let me get camera back in place. And share the screen again. So yeah, in Tecton, I have created, as you can see, I had to learn Tecton as I was going between yesterday and today. So if I did something weird, please tell me. So I created a task for running Jumpstarter, and I also have an image built for this that includes the Jumpstarter software. It says UV9, but it's actually CentOS Stream. I have to change that name. What this task is doing is, first I have a step that is listing the devices, then I need to break this step in two, but the first step is getting an image that we have built. Jumpstarter is not about building the images, it's about testing the images that you have built, so I'm excluding that from this workflow. The idea is that we receive the image from a previous step on the pipeline, so maybe you are calling image builder or you are using something else to build your image. And so we in this step, we get the image and we inject an SSH key so we can connect later with Ansible. And when we have modified the image, we just run the script. So let me show you how this looks. If I run it again, I will set it to run so you can see it running. Hopefully, if everything wants to work, you know, demos, like demos. So this is cloning a repository that I have here that has this script, okay, with the power off, set disk image, attach, blah, 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 blah. Then it's checking that some NVIDIA kernel modules are loaded in that edge system that I showed you. And then at some point is continuing in Ansible because I want to do more complex things. I want to list all the devices. I want to download the NVIDIA container runtime, run some of the examples that they have for this specific Jetson device. And then when it finishes, I want to capture the artifacts so I can put those artifacts back in Tecton. So you will get results. If something goes wrong, you will get details. So now if I go into this part of the pipeline, you see that the first step is listing the Jumpstarter devices that I have attached to this OpenShift node. If it was a bigger deployment, you will, see the demo, the demo gods, making fun of me. So if you see, I had a bunch of devices connected to this node, and one is with an Orin NX device from NVIDIA, another one is a previous generation Xavier NX, and the other one is the RISC-V board that I have for testing. If this had worked, I think I have an issue with guest mount inside the container, but it was working before. Probably I didn't clean up on my previous session or something, but I can go to the other run and I can show you how it's supposed to work. Whoa. So you will see that this is preparing the image. And then at some point, we copy the scripts, the working directory, and we run Jumpstarter. And then Jumpstarter is it's copying the image into the device, booting the device on, and waiting for the login. So at some point, the login is available here, yeah. And yeah, and you can, and we continue with the script. And then at some point when the system is ready, because we need to reboot it at some point, we run Ansible to gather additional details. And this is the point where we generate an inventory for that device and we let Ansible continue. And then we get the artifacts from that, and the cleanup is going to power off and detach the storage. Yeah, anyway, the other run, I think it's it's still continuing. It will eventually fail because, yeah, it's running on, it will eventually fail on the Ansible part because without guest mount, I was not able to inject the SSH key, but this is running on the hardware. So if I turn the camera to the other side, and I don't know, you can see my camera. This is the device running and being tested within Tecton. Let me switch off screen sharing.
So thanks, Miguel. We have a couple of questions. Dwayne, do you want to ask your questions online? Are you? All right, maybe Dwayne will be back. He has a couple. Oh, there you are. Do you want to ask your questions? Otherwise, we'll just ask them. You're welcome to mute if you would like. I think you're not unmuted yet. I'm not sure if I can do that for you. No, I don't hear you yet. I'll go ahead and start asking your question and then we'll see if you can. Okay, so Dwayne has a great question. He said, why not use Raspberry Pi or with OpenVLC? What do you think, Miguel?
Yeah, I mean, it's similar to OpenVLC. I'm not familiar with it. That one is like a KVM. Let me look it up.
Well, what about the Raspberry Pi? Can you do this using a Raspberry Pi?
I mean, you could connect. I mean, the idea on Jumpstarter is that we have like a driver architecture, and we have a driver for this testing system, the open source board for Jumpstarter board. We have a driver for that, but the idea is that we can write a driver for anything else. We could write a driver for the Raspberry Pi GPIOs, and then put one of those hats that has relays and lets you switch on and switch off things. So technically, we could run Jumpstarter on a Raspberry Pi and add the driver for that. So then the power on control will be on in a GPIO pin. The console to the device will be over some of the pins of the Raspberry Pi. So technically, yes.
Oh, can you hear me now?
Yeah.
Yeah. So the Open VLC, it's a Li-Fi spec, the open source way for Li-Fi, and they're working on their hardware for that. So I was thinking maybe you could put two things on one board, but I know they're in need of board hardware support too.
Yeah. Do you have a link to the project? I can have a look.
I could let me look it up real quick and I'll put it in chat.
Thank you.
So I also dropped in chat the Jumpstarter link to the Jumpstarter GitHub.
Yeah.
So
And I can share the. I have this repository. Please, it's it's not finished. I need to finish the work for Tecton and push it there. But it's there. You can see the scripts that I was running on the on Jumpstarter, and also the task and the pipeline that I wrote for Tecton. Which, by the way, I was not. I mean, I knew about Tecton, but I didn't have any hands-on experience. I really liked it. It's super powerful. And, yeah.
thanks, Dwayne.
Thank you.
Dwayne dropped it in chat. I'll put it in the notes. But is there a lab, or should people just go to the jumpstarter.dev URL, Miguel? Follow-up question is, I would love to see, you know, how to put that together, like your whole home lab there for Jumpstarter. Do you have a list of equipment, and can that be put into the repo, or?
Not yet. So today, you just need to use it. You just need a Linux system, and then one of the Jumpstarter boards, and then something to put on the Jumpstarter board. I don't. It could be a Raspberry Pi, for example. You could connect. In fact, I need to document how to connect the Raspberry Pi. If you go to the website, there is one of the sections. Let me. Yeah. For example, this one, I will share it on the chat. This is how you connect the Jumpstarter board to an Orin AGX, but we have another section for a Raspberry Pi. So you could, if you are building an image for a Raspberry Pi, you could test it with this. But yeah, so the whole idea of the project is trying to make the testing of those edge devices easier for Red Hat partners and for customers, so they don't need to manually test every time there is a new RHEL kernel. Every time they have a new version of their application, they can automate everything in the same way that they automate cloud software. Only they need to have a lab with the physical devices. Yeah, and something that I want to work on is having support for other types of hardware. I will look at that Open VLC project to see if we have a way to work with them. And yeah, to have drivers for other hardware, because the idea of the Jumpstarter project is not only that we want to support this board. This board was just a way to enable this for everybody, but we'll and make it easy, so they don't need to connect too many things around and do many manual work to get it working. But we really want to make it easy for other people to write drivers if they already have something. Some people is testing with smart plugs, for example. They have a smart plug that is switching on and off the device, and then they connect the device to the network and the console of the device to a server. So we will want to enable using Jumpstarter like that too.
I know we have 2 minutes left, so I think we have time for maybe one question. There's one last minute question. Thank you, Miguel. Really excited about this. And I want to know if Dwayne tries it. And I know there's other community members that couldn't make it today that will probably try, so. Okay. 1 minute left. Thank you, Miguel. Was there anything that a call to action? Go check out the repo. see what you're doing?
Yeah, I mean, call for action. If you can have a look at the website, and if you have any use case where you think this is valuable to your project or your company because you are working on the edge, just ping me. I'm happy to look at improvements for the project.
Thank you.
Thank you very much for having us.
Thank you so much, both you and Pablo. Appreciate it. Okay, thank you, everybody.
Thank you.
And we'll see you soon. Okay. And Miguel is in the OpenShift Commons Slack. If you want to just in the general channel, that might be easy. We could catch up there too. Okay. All right. Thanks, everyone. Bye.
Thank you. Bye.